Well, hi there, boys and girls. We're going to go through a couple more examples of U substitution, and I'm going to call this U substitution maybe some hard stuff because it's a little trickier. And you can see from this integral, this looks pretty messy, but I would like to offer you some hope. This is much easier than if that was just sine cubed of 3x. We're going to find out that we're very thankful that that cosine of 3x dx is right there. I want you to rewrite this, however, as the integral of sine of 3x, and this is all being raised to the third power, and then times cosine of 3x dx. So I'm going to use U substitution here, and I'm going to let sine of 3x be my U. The reason I'm going to do that is because cosine of 3x is close to the derivative of sine of 3x. So let's find out what our du dx is. Our du dx is cosine of 3x times 3 because of the chain rule. Now that's not exactly what I have here. I do not have the times 3. Now I'm going to embrace the shortcut, which we talked about yesterday, which means I'm going to put a times 3 in this problem. I'll put it right here, but then I'll divide by 3 out here. So I have created what I'm going to call a perfect inner derivative. Perfect inner derivative. So now I can apply my power rule. And that means this is my u, and I've got the perfect inner derivative there. So my antiderivative is going to be the sine of 3x to the fourth over 4, but we also have that 1/3 there. And so that becomes 1/12 sine of 3x to the fourth plus c. And so that is why it is d. 1/12 sine to the fourth power of 3x plus c. Alright, so that looked pretty messy, but believe me, I'm very thankful that that cosine of 3x was there. Alright, now let's do a different one. Here is the first time that I have a definite integral, and I'm going to show you something that you can do. And if you have a definite integral, you do not have to back substitute in terms of x. Let me show you what I mean. We would let u equal x cubed plus 8. So du dx is 3x squared. And I'm going to go ahead and do a full substitution here. So I'm going to solve this for x squared dx because that's what I have here is x squared dx. So that says 1/3 du equals x squared dx. But what about these definite numbers here, the 0 and 1? These are x equals 0 and x equals 1. If I'm going to do a full U substitution, I have to change those numbers as well. This is going to be a complete change of variable. So let's see what happens. I've got my u as x cubed plus 8, so there's my u squared. X squared dx was 1/3 du. But now what about the numbers? It is no longer from 0 to 1. And here is the equation that relates x and u. So let's talk about if x is 0. If x equals 0, then u equals x cubed plus 8. So u on the bottom here is 8. Then what about if x equals 1? If x equals 1, then u equals 1 cubed plus 8, and that's 9. So I've done a complete change of variable. I'm going to solve this all in terms of u, and I'm not even going to back substitute because I have a definite integral here. So the answer to this integral is u cubed over 3. And I've got my 1/3. I'm going to do that at the very end. And this is evaluated between 8 and 9. So from the fundamental theorem of calculus, we plug in the 9 first. And this is all times 1/3. 9 cubed, 9 times 9 is 81, times 9 is 729 over 3. And then we plug in the 8. Now 8 cubed, 8 times 8 is 64, and I'm not sure I know what 64 times 8 is. 4 is 32, 3, 8 times 6, it's 512. 512 over 3. Okay, so let's just keep going here. 1/3 times, if we subtract these, we get, what's that, 217 over 3. which gives me 217 over 9. I never back substituted in for x. I kept everything in terms of u. Alright, I want to work one of your homework problems that's probably one of the most scary looking problems on your homework. Again, this is called U substitution hard stuff for a reason. Alright, I am going to let u equal 1 plus the square root of x, because that's down here, and that has a power on it. Now, I can take my derivative of this, so that I've got du dx is equal to 1 over 2 square roots of x. Now, what do I have left over? If this is my u, I've got 1 over the square root of x, but I don't have 1 over 2 square roots of x. So I'm going to multiply both sides by 2, and I'll get that 2 du equals dx over the square root of x, which is what I have. So let's go ahead and do our antiderivative symbol. And then I have my 2 du will be the dx over the square root of x. So that 2 du is up here. That represents the dx and the square root of x in the bottom. And then on the bottom, I have u squared. Now what about these numbers? These are x equals 1 and x equals 9. So if x equals 1, then u equals, from this equation right here, u equals 1 plus the square root of 1, which is 2. So this bottom number is a 2. Then what about when x equals 9? If x equals 9, u equals 1 plus the square root of 9, which is 4. So I have turned that big messy thing with a complete change of variable into something a little easier. Now we know from our properties of integrals, I can pull that 2 out in front. So I've got du over u squared, which is the same thing as u to the negative 2 du. So now I'm going to find my antiderivative. Well, that is, you add 1 and divide by that, so that's negative 1 over u, which that's negative u to the negative 1, which is negative 1 over u, evaluated from 2 to 4. Alright, so we're going to plug in the 4, and then minus plug in the 2. And of course, when we plug in the 2, when we subtract the negative, it becomes positive. So I get 2 times 1/4, and I get 1/2. And that is the answer to the problem. And be patient with the problems you have to do tomorrow. There's 1, 2, 3, 4, 5. There's 9 of them, and they're not going to be easy. Be patient, try some things, and ask me for help, and I will see you guys then.